everyone. Today we are going to discuss another class of physics. This class or this presentation is for grade 10. We still at block 4. This presentation is for week 5. Is delivered to you or presented by me, Mr. Khalid. I think we stop at page 263, so please open your book on page 263. Last time we discussed and last topic is a resistance and we take a look for measuring a resistance, how changing resistance affects currents, and we stop at this title here, effects of length and cross-sectional area. So there are two things here which strongly affect a resistance. They are length and cross-sectional area. We are going to discuss what's the effect of both of them. So first we will check for how does length affect a resistance, and then we will move to another one which is cross-sectional area. For any particular conductor, like here in this circuit we have a power supply and some conductor here, any metal or any kind of conductor. So for any particular conductor, the resistance is proportional to what? To length. Is proportional to length. How? We can say that the longer the conductor, so if this distance is longer, so the further what the electrons have to travel. So the electrons need to move through all this area here, all the way from here up to here. So the longer the conductor, the further the electrons have to travel. So what does it mean? So this, the more likely what they are to collide with with metal ions, and so the greater the resistance. So there will be more resistance across this distance here. Why? Because there is what? Collide with what? With metal ion. Because of collide with metal ion, so the resistance will be higher or be greater. So if the conductor is more longer, the conclusion is if the conductor here is more longer, if we take this distance here up to here, from here up to here, and there is no this wire here or this metal here, so the resistance will be less. If we increase the length of what? Of this conductor, for example up to here, so the resistance will be more. If we take up to here, so the resistance will be more than the two previous parts. So the conclusion is the longer the conductor, the further the electrons have to travel. So the more likely they are to what? Collide with metal ions. That because what? They are collide with metal ions. So for example here, any wire, if we have any wire, the wire of metal or something, or copper, it's very good conductor. So a wire that is twice as long will have what? Twice as much resistance. So if the wire is twice, for example this first part, we add second part here. If the wire is twice, so the resistance is what? If the resistance here is R1, so the resistance from here up to here is 2R1 or 2R. So the resistance will be twice. Okay, now so this is for first one or first factor here to affect the resistance, which is the length of what the conductor. Now we will move to another thing, which is cross-sectional area. So as we can see here, this is an cross-sectional area. If we have one part here, or we have like twice of cross-sectional area. Actually, we can say a resistance is what inversely proportional to what the cross-sectional area of the wire. How? The greater the cross-sectional area, the greater, if we have one section here, this is another sectional here, one part here, is if we add another part here, what will happen? The greater the cross-sectional area of any conductor, so the more what electrons are what available. There are more electrons available here. If we have like 10 electrons here, so we will have another 10 here. So the more what electrons they are available to carry what the charge along the conductor is, or the conductor length. So the lower resistance, we will have what? The lower resistance. So this one is what it is different from what length. It gives like opposite result. For that one, for this one, a wire with the twice sectional area will have what? Half resistance. Half resistance. Resistance will be less. Why? Because the electrons they will be more. The electrons they will be more. So now we have two factors or two things to affect what resistance: cross-sectional area and the length of what conductor. For the length of conductor, if we have a twice length of the conductor, so we will have what like less, where half a resistance or half twice what a resistance, so the resistance will be more. Here with the cross-sectional area, if we have like a wire with the twice cross-sectional area, two cross-sectional area, so we'll have what? We will have half resistance. So they are what those two factors or those two things, length and cross-sectional area, they have opposite what effect on resistance. Okay. Now we'll move to what? Electrical energy. The title or subtitle of electrical energy on page 265. So what's electrical energy? As we know, all electrical equipments that they are connected in the circuit, or they're gonna take a power, or has what? A power rating. So all electrical equipment in electrical circuit has what? Has a power rating. So what's a power rating? What do you mean by power rating? Power rating, which what indicates how many joules of energy are supplied each second. How many joules are supplied of energy of each second. So if we have, for example, a lamp, normal lamp, or light bulbs here is often have a power rating of what? Usually 60 watt, 100 watt, 200 watt. This is the normal one. It's 60, 100, 200, it's up to 500 sometimes watt. There is another electrical equipment. For example, if we take electric kettle or electric kettles, have a rating of about how much? 2 2 kilowatts. It's more. It's 60 watt. Here is what? 2 kilowatt. It's about 2000 watt. So now a 2 kilowatt kettle supplies it supplies about 2000 joules of energy each second wear to the circuit component. So now power rating, what do you mean by power rating? The power rating, it's like what? Indicator to how many joules of energy are supplied each second by what? By this electrical equipment. For example, if we take a light lamp or bulbs, it's often have how many power rating? It's 60 watt or 100 watt or 200 watt. If we take another electrical equipment like kettles, it has a rating of what? 2 kilowatts. 2 kilowatts. 2 kilowatts means we will have 2000 joules of energy every or each second to wear to the circuit component. So that's this is the definition or the explanation of what power rating or electrical energy. Okay, now we have we are going to take example here for more explanation. The power of a piece of electrical equipment, any piece of electrical equipment depends on what? On voltage and what? Current. It depends on what? On voltage and current. So the units here, what is watt? The power energy of this one is watt. So 1 watt is equal to what? 1 joules per second. If we take a volt, 1 volt is equal to 1 joules per coulomb. If we take 1 ampere current, 1 ampere is equal to 1 coulomb per second. So it depends on, so the unit or the units watt, volt and ampere are defined by those like, it's not a question, it's like what do you call it? It's like a definition. 1 watt is equal to 1 joules per second, 1 volt is equal to 1 joules per coulomb, 1 ampere is equal to 1 coulomb per 1 second. They are all correct. They gives the same meaning here. So now from these definitions here, those definitions here, we can say what? That 1 watt is equal to what? 1 volt times 1 ampere. Yes. 1 joule, 1 watt is equal to what? 1 volt times 1 ampere. In other words, so what's the definition of this one, or the what do you mean? The formula of this one? Power is equal to what? The power of any equipment, any bias electrical equipment, the power of it, or the power consumption is not consumption. The power of this equipment is equal to what? Current times voltage. Current times voltage. Keep this equation here. This equation, this general formula. So P, which is the power, is equal to what? I times V. So what's B? B power in what? In watt, as we say here. P is the power in watts. I is the current in what? In amperes. V is what? It's voltage, or yes, voltage. V. So now you can, for easy, for easier way to remember this formula here, use always this triangle. Always use this triangle. If you are going to, for example, calculate I, hide I by your hand. So I is equal P over V. V is equal B over I. What do they call? B is equal what? I times V. B is equal I times B. P is a power in watt. I is current in ampere, V is a voltage by fault. It's a voltage by fault. It's easy. It's to help you what rearrange this equation. Okay. Now we will move to page 266. Page 266. Energy, current, voltage, and time. Now we will go more more advanced in those topics. We will say what's the relation between energy, current, voltage, and time. Energy, current, voltage, and time. Okay. Okay, as we said, now we are going to say what's the relation between energy, current, voltage, and time. Actually, this relation, as we said in last slides, this relation is controlled, but finally it's controlled by what? General formula. It's controlled by general formula. So to find the relation between energy, current, voltage, and time, if you switch, for example, we will take an example here. If you switch an electrical kettle for 1 minute, or a room heater for 5 minutes, then you can measure what? Temperature. You can say that the temperature is what? Increases. Or the temperature what? Increase of what? Of water in where? In the kettle, or where? In the room. So there an increase in what? In temperature. The temperature will increase because of what? Because energy has been given to where? To water. There is an energy, transferring energy from where? From this equipment, which is for example electrical kettle, or I don't know, the heater, or can use air condition. Sometimes you can use air condition. So there is what? An energy transfer energy from where? From those equipments to where? To the water or to the room. So the temperature will increase because what? Energy has been given to the water or to the room. Energy is what? Energy is measured, as we said before, in joules. J. Energy is measured in joules. So for example, if we have a heater rated at 1 watt, will give out what? 1 joule of heat each second. So there is a relation between a heat, what do you call, watt, the power of this one, will give out 1 joule of heat every what? Every second. Okay, another example. If we have 2 kilowatt heater, now 2 kilowatt heater will give out how many? It will give out 2000 joule per second. And if the heater is switched on for 4 seconds, so they will give how many joules? They will give 2000 times 4 seconds, because 2000 with 2 kilo in 1 second. If we have 4 seconds, so we will have how many joules? 8000 joule. So finally, what's the relation between? We have to take this example to get what? To reach to this general formula. So energy is equal to what? Current times voltage times time. Energy is E is equal to current times voltage times T. So E is energy transferred in joules, J, I current in amperes, A voltage is a volt phi, T is a time in what? in second. So it could be sometimes in not a second, in minute. This one could be in milliampere. So we need to have the same the same values, amperes, volts, second, joules. So the final relation or final formula or equation to control all those things here, energy, current, voltage, and time, is energy is equal to current times voltage times time. E is equal I phi, I times phi times T. Okay. Now we will move to another section, or it's not a section. We are going to solve some questions in your textbook. We will take random ones, solved and unsolved questions from your textbook to cover different topics for the last presentation and this presentation. So please start on page 257. 257. What we'll have here, we have question number 1. Question number 1 say, calculate the flow of a charge in what? In the following here, A, B, C, and D. Current, so we need to find flow of a charge. If we have a current 3 ampere for 5 seconds, then we will again we will find flow of a charge of current 2 ampere for 10 seconds. Again we will find flow of a charge of current 4 ampere for 23 seconds. D, we have a little bit different. We have a current 1.5 ampere for what? 0.5 minute, not second. So we need to find for all of those A, B, C, and D, we need to find what flow of charge. Okay, now just keep this triangle for the formula in your mind. You need to keep it in mind. So what we have here, flow of charge is what? Is Q, as we mentioned it in last presentation. Q and I is current, T is time. Q, I, T. So now in this equation we are going to find what flow of a charge, which is what? Q. Put your hand on Q. So Q is equal to what? Here, for example, in this one, Q is equal to I, current, times what? T, time. Time in what? In second. Must be in second, not in minute. So for section A, Q is equal to what? We have what? 3 ampere. 3 times what? 5. 3 times 5 is equal to what? 15. 15 what? Column. 15 column. Number B, or section B, is same. Q is equal I times V is equal to what? 2 times 10. 2 times 10 is equal to what? 20. This for section B. Section C is same, exactly same. So Q is equal 4 times 23 is equal to what? I think 9, yes, 92. 92 what? Column. Last one, D, current is equal 1.5 ampere and time is equal to what? Minute. We need to change from minute to what? Second. So Q, we are going to use the same equation. Q is equal I times T. So Q is equal to what? 1.5 times 0.5 times 60. We need to change from minute to second. So the final result will be 60 30, it's 45. Yes, it's 45 column. It's very easy. It's all you need. This triangle or this formula. Flow of charge is equal to what? I times T. I is equal to what? Q over T. T is equal Q over I. Okay. Next question. Here we have what? A charge of what? 120. Charge is what? Is Q. So what we have here? Q is equal to 120. What we have also for what? For minutes. Minute, which is T. So we have a Q. We have what? T. T is equal to what? T is equal to 4 minutes. So what's the current? We need to find what? I. We need to find I. I from this triangle, I is equal to what? Q over T. Q over T. Try yourself. Try yourself. Okay. So now I'll give you the result. A charge, but please, before you get the result from me, try yourself first. Try yourself first, then check the result. So we have a charge of 120, which is, as we said, Q, and we have what? T. As we said before, charge must be in column, and time must be in what? In second, not in minute, in second. And current should be in what? Ampere. So now we have what? I, as we said, I is equal to Q over T. The Q is equal to what? 120. And this one, T, is what? 4 times 60. We need to change it from minute to second. So the result is what? 120 over 60 over over 4 over 60. Or multiply those first and then divide. Or you can say what? 120 over 4 over 60. So the result is equal to I think it will be, yes, 0.5 ampere. 0.5 ampere. Okay. Now we'll move to another question. It's the same. I think I will leave this for you. A charge of 60 coulomb. We have 60 coulomb of a charge Q. Produces a current of 0.5 ampere. So how long does this take? How long does this take? It's a time. How long is the time? So we have what? The Q. We have I. We need to find what? T. T is equal to what? Q over I. Q over I. It will be, the Q is 60. 60 over 0.5. Yes, it's easy. It's try yourself. Okay, now we will move to another worked example. It's another example here. It's on page, it's located in page 260. So in this two examples here, what we will have here, we have a heater device or equipment of a heater. A heater element is connected to what? 230 volt supply. 230 volt supply. Then the current or the current in the heater is what? 10 ampere. 10 ampere. Calculate the resistance of the heater. Calculate the resistance of the heater. From previous presentation or class, we have R is equal to what? We did prove or find a relation or a formula between R, V and I. R is equal to what? V over I. This is what do you call this one? This is a resistance, this is a fault, this is what? I. So V is equal to what? V is equal to I times R. V is equal, it's easy to swap them. So this formula is not, this formula R is equal V over I, which is what? It's Ohm's law. Ohm's law. So first we need to write down the formula in terms of R. So then we'll substitute the values of V and I. R is equal to what? R is, we need to calculate it. Resistance, we need to calculate the resistance. And we have V are given here. And I also is given in question. So R is equal to 230 over what? 10. 230 over 10, 0 with 0. So R is equal to 23 ohm. 23 ohm. Question number 2, or worked example number 2. We have what? 6-volt supply. 6-volt supply. It's battery or anything. Battery power supply. It supplies what? Or 6-volt. This 6-volt supply is applied what? 1000 ohm resistor. 1000 ohm resistor. So this is what? R. This is R. Is given in question. What will be the current? What will be the current? So I is what? Unknown. I. We need to find what? I. And we have what? 6-volt power supply. So V is equal to what? 6. This is V. V is equal to 6. R is equal to 1000 ohm. We need to find what? I. First write the formula. So I is equal to the same one here. Swap them. I is equal to what? V over I. So V is 6. I is 1000. V is 6. I is 1000. So we have 3 zeros here. First 0. Second one after this one 0, 0, 0, 6 ampere. So we have 0.006 ampere. Okay, this is Ohm's law. Ohm's law. I or V or R, any one of them. V is equal to I times what? R. So then easy to find any one of them. Okay. Now we will move to another question on the same base. Question is in your textbook. I think on the same base. Yep. Question number 1. Use Ohm's law equation, which we will discuss in the last slide. So use the Ohm's law equation to calculate the potential difference, which is V voltage across 5 ohm resistor, which has a current of 2 ampere in it. I will give you like 1 minute to think about it. Try to think about it. Solve it by yourself first. Okay. Did you get the result? So how we are going to use this one? First we need to write down the equation of Ohm's law, which is, now we have R. In this question we have R and I. So from Ohm's law, from this law, we have what? V is equal to I current, times what? R. It's a current times R. It's equal to, we have 2 ampere times what? 5 ohm times 5 ohm, which is equal to 10 what? Volt. 10 volt. We have R here, I here, and then we need to find what? V. V is, we need to calculate V. So just write down the Ohm's law, then substitute the values here in this equation. You will get what? You will get V. Okay. Second question. We have a lamp has what? A value of voltage equal to 3 volt. 3 volt cross it. So V is, voltage is 3 and current is 0.5 ampere in it. So what's the resistance? What is the resistance of this lamp? So what we have here, what will V is given in question is equal to what? 3 voltage, and then current I is given also in question, which is equal to what? 0.5 ampere. Just notice that we can write it A or AMB. Ampere. A or AMB, same. And then what? We need to find what? R. We need to find R. So what's the value of R? R is equal to what? From Ohm's law, R is equal to V over I. R is equal to V over I. So V is what? V is 3 over what? 0.5. 3 over 0.5 ampere. So it's equal to what? 3 over 1 over 2. 2 is where? To here. So it's equal to 6 ohm. 6 ohm. So the resistance that makes the voltage on this lamp equal to 3 with current 0.5, it must be what? 6 ohm. 6 ohm. Okay. It's another worked example or examples on page 266. So what we have here? We have what? What's the power of a balance when a current of 7 ampere is obtained from 230 volt supply? So we have what? Power. We need to calculate P. B is here. When current I is equal to what? 7. From power supply is what? 23 or 230 volt. From this presentation today, from first slides, we said that P is equal to what? V times I. B is equal to V times I. B. So first we need to write down the formula. Always follow this steps, two steps here. First, write down the formula. Second, substitute the values in the formula. So B is equal to phi is 230 times what? 7. So the final result is equal to 1610. 1610. It's another example here. We have an electrical oven, has a power rating of 2 kilowatt. What will the current be when the oven is used with 230 volt supply? So what we have here, we have B. So power rating, the power is 2 kilowatt. It means what? 2000 watt. 2000 watt. First we need to change it. So first write the formula. I is equal to B over V. Then substitute the values. I is equal to 2000, which is 2 kilowatt. 2000 over what? 230 volt. 0 with 0. So 200 over what? 23. It's equal to what? 8.7 ampere. 8.7 ampere. Okay. The same question here is the same. We have what? Current is 2 ampere. I is equal to 2 ampere, and then in it, and operates at what? 110 volt. So what's the power rating? So what's the power rating? As we said here in last slide, B is equal to V times I. B, we can say that B, which is the power rating, V times what? I. We have what here? 2 ampere. I is 2 ampere times 100. So you can find what? B. You can find the power rating. 220. So the power rating is what? 220 watt. It's equal to 20 watt. So we need 220 watt to let this equipment operate at 110 volt with the current of 2 ampere. Just write down the formula and then substitute the values. Question number 2, it's same, exactly same. We have what? We have 60 watt. So B, the power rating is 60. This is a lamp, has a current of I is equal to what? 5 ampere. At what voltage is it operating? So what's the value of V? As we said before, B, write down the formula. B is equal to V times I. So we can say that V is equal to B over I. It's equal to what? 60 over what? 5 ampere. It is 60 over 5 ampere, which is equal to what? 12 what? Volt. 12 volt. Okay. Third one is for you. Try yourself. It's very easy. We have to 25 watt, designed to be used with a voltage of 230 volt. So we need to find what? I. We need to find I. It's very easy. I think now we will move to page 267. So in this question number 1, on page 267, question said a laptop charger is designed for a country where the mains voltage is 230 volt. The owner takes the charger to a country such as USA where the mains voltage is what? 110 volt. So the question is, will they be able to charge their laptop? Able or not? We don't know. How? Now we have how many voltage here? So a laptop charger is designed for a country where the mains voltage is 230. So this charger to work, it needs what? 230 volt. So the owner takes, if someone traveling to countries like USA, Canada, the mains voltage there is 110. It's 110 volts. It's not gonna work. So will they be able to charge their laptop? No, it's not possible. No. Why? Because the voltage is not enough. This charger needs what? Needs 230 volt. Is designed to consume or to have a voltage of 230 volt, and then we will take it to another country like USA or Canada, and then when you put it in the plug, it will get only 110 volt. So it's not going to work because the voltage is not enough. Okay. Question number 2, we have a heater which runs on 12 volt, transfers 4800 joule of energy in 2 minutes. So what's the current in the heater? Just use what? This triangle. I is equal to what? I is equal to we need to find what the current. What is the current in the heater? I is equal to P, it's what? Power over V. B is what? B over V. We have what? Time is here. So it's in 2 minutes. We need to find what? I. So what's the formula here? The formula is, as we said before, question number 3. Yes, number 3. Okay, I think we put the wrong formula here. Yeah, this one is wrong. We are not looking for this one. So we have a heater which runs on what? 12 volt, transfers what? 4800 joules. So we need to write the equation of what? E, which is energy, which we I think this equation we discussed today in this first slide. Is E is equal to what? I times V times T. Energy is equal to I, current, times volt times T. You can find it in the last, I think, slides before we start solve the questions. So E is equal to what? We put the wrong one here. E is equal to I times V times T. So energy is what? We have 4000. Now first step, always use this way. First step, write the formula. Second one, what? Substitute what? The values. So the value of E is what? E is equal to 4,800 4,800 joules of energy in what? In 2 minutes. In 2 minutes. So time must be in what? Second. In second. So it's equal to what? I. We need to find what? I. What is the current in the heater? So I. We are looking for what? For I. Times V. V is what? 12. 12 volt. Times what? 2. T is time. Time in what? In second, not a minute. So time is 2 times what? 60. 60 is to transfer from minute to second. So what's I? What's the value of I? I is equal to what? 4,800. Sorry, it's hard to write with the mouse. 4,800 over what? Over 12 times 2 times 60. So we can find what? The value of I. So now just divide 4,800 over 12 over 2 over 60, or times multiply 12 times 2 times 60, and then define this one with the final result here. Or for easy way, divide 4,800 over 12 over 2 over 60. I think the result will be I think 33. Yep, I think 33. 3.333 ampere. So this is the final result. So this heater will transfer current of 3.333 ampere. Okay. Number 5. Again, we use this the wrong one. Sorry for that. We use the wrong one. We have a lamp transfers 24 joule of energy. So E is equal to what? 24, and throws a current of what? I is equal to what? 2 ampere for 1 second. Time is what? 1 second. Okay, 1 second. So what's the voltage is it operating at? So what's the value of V to make this lamp operate? As we said before, it's very easy. Write down the formula. E is equal to what? I times V times T. We need to find what? V. So V is equal to E over I times T. It's equal to what? 24 over I is 2 times T is 1. It's equal to what? 12 volt. It's 12 volt. Okay, I think this is all for today. Yes, this is all for today. I think we pay more attention for the questions, so please try to solve it yourself first. Write down the formula, write down what the values that are given in the question, and then substitute the values in any question. It the most important thing that you need to memorize the formula. Write the formula, substitute the values, and then find uh, or calculate what is unknown in the formula. So I think this is all for today. Thanks for your listening. If you have any question, please feel free to contact me, and we will see you next week inshallah. Thanks for listening.